Hi students, this is AJ sir. Let's study 9th standard ICSE Math exercise 8C. In this exercise, mark the sums 5.3 and 11th as IMP and even 1.2. Let's start with 1.1. We want log 4 and they've given log 8. This log 8, let's convert it to a log 2 because 8 is 2 cube. And then we'll use log 2 to find all the values out here. So just once you need to convert it. Log 2 cube. The exponent becomes the coefficient here. 3 goes down, you get the value of log 2. I'm not writing base 10 anymore. It's understood. By the way, the base 10 is not called a natural base, and such logarithms are not natural logarithms. Now, the question is log 4, which is also a power of 2. That's 2 squared. So 2 goes here, and then substitute the value of log 2 so that you get the final answer as 0.60. Similarly, for the Roman number 2, first convert log of root 32 into a power of 2. 32 is 2 raised to 5 and square root means power of half. So together I'm writing it as 2 raised to 5 upon 2. So the power becomes the coefficient here, and log 2's value we know. Substitute that value of log 2 to get the final answer. Next, 2.1. In question 2.1, again it's a similar type of sum, but this time they have given log of 27, so we can convert this into a log of 3 because 27 is 3 cube. So I've done that. So again the power becomes a coefficient, it goes down, and after dividing I get log 3 is this, which can be used to solve all the sums of this section. They want log 300 in Roman number 2. Actually this is Roman number 2. So 300 can be written as 3 into 100 and split it into 2 logs, log 3 plus log 100. Log 3's value we know, so use that. And log 100 we know is always 2. So the final answer is 2.477. Next, in question 3, they've given if log of A is equal to B, then find the value of this in terms of A. So here the first thing we'll do is we'll convert the logarithmic equation into an exponential form of equation. Remember, the base raised to this is equal to this was the exponential form. Now, this is the given question. Split it up. Minus means division of the bases with the same powers. These are laws of indices which we've studied in some previous chapter. And also 10 raised to 3b can be written as 10 raised to b the whole cube. And now 10 raised to b, if you remember here, is equal to a. So substitute this as a cube, and 10 squared is of course 100. So we got the answer in terms of a. Next, 5.1. Here, given that log of m is x and log of n is y, express this in terms of m. Note here the base is 3, which means that we will have to write it. Only if the base was 10, then it's okay if you don't write it. But if its base is something else, you have to mention that in every step. So as you can guess, first we shall convert both the logs into the exponential forms. That is, this base raised to this gives you this. Same way here. So 2 exponential equations. Now, this is the question for Roman number 1. So as expected, split it up. It becomes 3 raised to 2x upon 3 cube. That becomes 3 raised to x squared, and 3 cube is 27. And now substitute the value of 3x as m. So this is the final answer. Now let's do Roman number 3. In Roman number 3, they have given this equation. They've given this equation. And they have asked us to find a, the value of a, in terms of m and n. So first of all, substitute the values of x and y as given in the question. So this is what is given in the question. So just substitute that. So now LHS and RHS, both of them have log. Good. Next, whatever coefficients were there, convert them into powers. So this raise becomes m raised to 5, this becomes n cube. Because we are trying to get all the logs together. Now there's a subtraction, so there will be division here. This is wrong here, we can't write this. So only one log. And that was our aim. If we have one log on both the sides with no coefficients, that is very important, with no coefficients, then the log will disappear. I'm not cutting the log, it's just comparing. So now I can say that a squared is equal to m raised to 5 upon n cube. But I want a alone as per the question, so the square goes and becomes square root. I could have also written this as m raised to 5 upon 2 and n raised to 3 upon 2. Even that is okay. Next, 6.2. Look carefully, this is not a subtraction sign, it's a division sign. So let's simplify it. Division means this upon this, of course. Yeah, two logs will come here. It's division, not subtraction here. And the power became a coefficient. Log A cut. So what is the final answer? 3 is the final answer. Now the seventh sum. If log of a plus b is equal to log a plus log b. If, yes, this is not always true. It's true only here. Don't think of this as a distributive multiplication. This is logarithm, not normal algebra. Find a in terms of b. So you can predict before solving this sum that you will have to get rid of log first of all. So how do we do that? Well, addition means you can get the logs together, so you get a single log. If you have single logs on LHS, RHS, we can get rid of it. So what is left is a plus b is equal to ab. But I want a alone as per the question. So I shift ab on the LHS and I shift b on the RHS. So I get a minus ab is equal to minus b. Here take a common. So what is left here is 1. When nothing is left, 1 is left. Minus b is equal to minus b. And I got a alone by sending this down. But let's write it in the standard form. I want to get rid of the minus sign. This can be accomplished by flipping the denominator. When you make it b minus 1, then the negative sign will disappear. Because when you write b minus 1, then this also becomes negative. And there was a negative, negative, and negative gets reduced. So the final answer is a is equal to b upon b minus 1. Yes, we have to write the final answer in this format, not like this. Now 8.2 is a proving sum. They've given one equation and they're asking us to prove something else. Here log is not there. That means we will have to get rid of log in the given equation. So let's start with that. This is the given equation. A becomes a power of b. And here b becomes a power of a. And minus 1 is shifted on the RHS to become positive 1. Well, to get rid of log, I want log on both the sides. So here let me write it as log 10, because 1 is nothing but log 10 to the base 10, of course. So log disappears by comparing and we get this, and this is what is asked. Now 9.1, if log of this is equal to log of this, find the value of a. A very simple sum. First of all, there's a subtraction out here. So get rid of the log, but first bring them together into a single log. The log disappears and only variables are left. Cross multiply and get the answer of a as 6. In 9.3 they want us to prove this. We have to prove this. So let's start with LHS. How do we simplify this? Well, 125 is 5 cube and the exponent becomes a coefficient. We can't solve it further, so let's leave it as it is. Now let's start with RHS. This is the RHS. I would like to get rid of the single log out here. I would like the entire thing to have a single log rather. So 1 is nothing but log 10. The reason why we have to write this as log 10 is because now log minus log, you can bring them together into a single log. That is log 10 upon 2. The 3 remains as it is. And this on reducing becomes 3 log 5, which is equal to the LHS, hence proved. And finally the 11th sum. This is given and we have to find the value of x. Note that the base is x, not 10. That means in every step we will have to write the base as x. So first of all, this log to the base x shifted to the LHS and only 2 will remain on the RHS. You cannot write this as log 100 in this sum. Of course 2 is log 100, but that is to the base 10 and these are to the base x. So the log cannot be disappeared like this. Then how can we get rid of log? Well, if you remember, there is one more way, the exponential form. So let us first get the logs together. So there was a subtraction here, so I did division of the numbers. And now there is an addition here, so do the multiplication of the fractions. So after reducing, finally I am left with log 1 upon 25 is equal to 2. If only this was a base 10, then we could have converted this into log to the base 10 and log would have disappeared. But that's a useless thing to think about right now. Instead, let's convert this into exponential form. The base raised to this is equal to this. And then square root x becomes equal to 1 upon 5. Negative value is not possible. The base is not negative for this sum.